Now, when we look at another example, and of course we have to consider equilibrium right here, this equilibrium process, we need to understand what these equilibrium arrows mean. From Gen Chem 2, specifically, if an arrow is larger, let's say the top arrow in this case is larger than the bottom arrow, because, or the one that's pointing to the products is larger, it means these right here are your major products, are your major species. So these would be the major species or products. We'll call them a species. Uh, So it says here, as the at the equilibrium, the weaker acid and weaker base are the major species found in the reaction mixture. So let's look at which one is the acid, which one is the base, etc. And then you will actually get to a point where you're going to draw the product. So if you look here on this side, it seems that the H on HCl was given up. So Cl is by itself. So this must be the acid. While if you have the acid, then this must be water, must be the base. So obviously, the pair of the acid must be called the conjugate. The pair of the acid must be called the conjugate base. Okay. And let me actually use the same color so you can actually see them better. So this will be the conjugate base. And of course, the conjugate of the base would be the conjugate acid. So we know what goes together. So these would go together. And of course, these, the HCl and the chloride ion, would go together. So these are the conjugate pairs. So it's important to remember is that strong acids have weak conjugate bases, and weak acids have strong conjugate bases. So let's actually go to some important generalization. If you notice here that in this example right here, is that electron-rich species react with electron-deficient ones. So the electron-rich species in this case was water. So water has its electrons. So it's electron-rich. While, of course, the HCl was electron-deficient, has no electrons. It's sharing again with chlorine, but of course, if you remember from polarity, it would be actually a delta plus on it. Okay, and this would be a delta minus. So this would be an electron deficient, or we call it electron poor. When only one starting material contains a hydrogen, it must be the acid. If only one starting material has a lone pair or a pi bond, it must be the base. So in this case, what we have is we have water with its lone pairs, right? So that actually determines that it's going to be the base. We don't have any pi bonds in this case, but we will see them later on. And of course, this HCl is a very known acid. A starting material with a net positive charge is usually the acid. So actually, let me go back to 2. So talking about pi bond, for example, is something like having, let's say, ethene. Like this would actually make it an electron base, an electron rich, or the base. You can think of it this way. We'll get to that, of course, a little bit later. Finally, a starting material with a net positive charge is usually the acid. So if you have something that begins with a net positive charge, something like H3O plus, if you start with that, then that must be your acid. And anything that has a negative, then that must be the base. So